47, and this is our project demo. Let's go ahead and get started. So first, this is on the ASU General server. We've SSH'd into both General 3 and General 4. And then to get the code onto the server, we've used GitHub. So if you type ls, you can see that we have the client and all the information that we need to get everything running. So we'll go ahead and compile the server first using G++. That compiles without error. We'll go ahead and run. And then client also compiles. And we'll go ahead and clear these out. So first we'll go ahead and start the server by saying /server.o and then 24,000. So that's the lower end of our range based on our group number. So we'll get that started, and then the server is going now. So same thing for the client. We'll go client.o. The server IP address is 10.120.70.105 as per ASU's general server. And then again, our port number is 24,000. Okay. And then we're going to go ahead and copy this, throw it into these guys. So for the first user, we'll call it user 0. And then sequentially, we'll just build up from 24,000. And then that operation completed. So we'll do user 1. And then user 2. Cool. And then based on our program right now, we've been unable to implement the type of program that can listen on the UDP and for standard in at the same time. So the user is asked to input the standard in manually. So for these two, we will have them wait for a ring connection. And then for the third, we will set up a ring of size 3. So you notice that happened pretty quickly, but this ring was the one that initiated the ring setup command. So the flag came back success, saying that coming from the server, saying that the server was able to find 3 users. So return flag 3 received. These were the 3 users that were selected. With user 2 at the bottom, such that we can pass the user data from one ring to the next, or from one peer to the next. So this was user 2 with the port information there. This was sent to user 0 here. And you'll notice flag 200 received from another user on port 24009. 24009 is the outbound port for user 2. And then same thing here. It said flag 200 received from another user on port 24003. 24003 is the outbound port on user 0. And then it finally received back on user 2 with the final information, thus indicating that the ring is complete. When I mentioned the flags are defined here within this .h file with a couple structs in it. Message is the typical message that is sent between either the users or the user and the client. The flag identifiers are listed out here. And these flag identifiers are used for us to denote through the message what type of action needs to be taken. And that also gives us kind of an error checking ability in that we can have the clients or the server wait for a certain flag number to come back in order to continue doing a certain action. And then we also have struct peer. Peer is also communicated between clients. And then the way that works is between clients. The first thing that happens, so say on user 2, as it connects to user 0 first, is it sends a message with flag 200, which is the flag that specifies that Let me double check that real quick. Yeah, so flag 200 identifies that ring information is incoming, and the specific ring information here is what the number of users that are going to be incoming. So that ring is sent, that message is sent, a message is sent back to the original user saying, hey, okay, I'm ready, using a different flag, and then one at a time. This user 2 will transmit a peer to user 0, rather, which then after completion, and since user 0 knows how many peers are incoming, after completion there, this user has the users that need to be assigned after that. User 0 then takes user 1, which is the top element in the string of sequential data that was sent, uses that as a connection, and then transmits the rest to user 2 or to user 1, which then connects back to user 2. So you notice that the sequence started with user 2. User 2 is added to the bottom of this so that the last user in the ring can successfully add back to the original user. And then coming back here to the server, you'll notice that after each stage, there's a current user base that's printed out. These were the 3 users that were selected for the ring. Originally, the current user base before it says ring of size 3 requested. The current user base before that, all 3 users were free. Then the ring of size 3 was requested, the return flag 13, saying that everything was ready for transmit. So it's the same kind of protocol between the server and the initiating client, where each peer is sent sequentially. These 3 users were sent, and then finally, when the user that initiated the ring receives a message from any other client, it knows that the ring has been completed, and then can communicate back to the server, which will then update the statuses of each element in the ring, such that user 2 is the leader, indicated by the L, and then user 0 and user 1 are in ring, denoted by the user I. Note also that when we set up the ports here, there's a server communication port, a left communication port, and a right communication port. We specified those in the very beginning, such that we are at this stage guaranteeing that communication will be sent in a uniform way, such that data is coming out of the right port and coming in on the left port. So that by design is already built into the client protocol, where each client is only listening on its left port to begin with, and each client is only sending out information on its right. So we can guarantee that things are properly aligned ahead of time. But that is our demo. Again, group 47. Yeah.